What's up, guys? We are here and we're going to be getting into some factoring. Everybody's favorite part of algebra, right? Factoring. Not really, it's kind of hard, but I'm going to walk you through it here. We're going to go through, there's a lot of different types of factoring with a lot of different processes, okay? So the one we're going to be talking about here first is GCF, factoring out a GCF from a group, okay? And I have these two different things here, and it's actually, if you notice, this would, like, if you distributed this 4x, this would actually be the answer to that. Okay, so I'm kind of giving you the answer ahead of time. But I want to focus on this process first and foremost, okay? Because that's going to help us do the rest of it. All right, so when you look at this one, right, obviously this 4x can be distributed. How do you know that? Well, it's a term multiplied by a group, right, a polynomial. And so when I have a term multiplied by a group, I can multiply the 4x times each of the terms that are in here. Okay, so 4x times x squared, okay? And then separately, 4x times 3, right? Two separate multiplications happening because there's two different terms in this group, okay? And so you might look at this and you think, okay, 4x times x squared, okay? And within each of these, you kind of multiply, right? So you'd multiply coefficient times coefficient. So that'd be 4 times 1 is just 4. So the 4 would remain the coefficient. But with these variables, right, this would be x to the first times x squared, okay? And if I was to expand that, it would be x times x times x, right? So really, it becomes x times x times x, 3x's, okay? Or x to the third, right? And the shortcut there would just be to add the exponents on your variables that are the same. Okay, and then in this one, right, this one doesn't have an x, so all I have to worry about is doing 4 times 3 is 12. That would be positive 12, so positive 12x, because that x stays there, right? And hey, what do you know? There's the answer right there, okay? But I wanted to show you that process because factoring out a GCF is the reversal of this process, okay? So you're probably familiar with this. You probably recognize it from Algebra 1, or even if you don't remember it exactly, hopefully it makes sense, okay? Because what we're going to do is when we factor out a GCF, we're starting with this, okay? And we're going to end with this, kind of the beginning of so that's what our answers look like, kind of the beginning of a distribution problem, okay? So first off, just a review here, GCF, what is GCF? GCF is greatest common factor, right? Okay, and a factor just means that's a number that multiplies to get a product or a higher number, okay? So, right, so when we look for greatest common factor, okay, keyword there being common, okay? So what we want to determine here is out of these two terms in this group, okay, what factors or what do they have in common that would divide evenly out of them? Okay, so 4x to the third and 12x. And so you kind of break it up. You break it up, right? So we look coefficients first. So the coefficients here are 4 and 12. Okay, so with 4 and 12, okay, with GCF, okay, sometimes it can be helpful to actually write out what all the factors are of these. Okay, you don't have to do this, but just as a reminder of how you would find the GCF, you'd think, okay, 4. What are all the numbers that multiply to give me 4? Like to get 4 as an answer. And so you could say, okay, 1 times 4 is 4, obviously, and then 2 times 2 is 4. Okay, so the factors of 4 would be 1, 2, and 4. Okay, and then for 12, you think, okay, what are all the numbers that multiply to get 12? So it would be 1 times 12 is 12, 2 times 6, and 3 times 4, right? And you don't have to write the reversal, right? So the factors of 12 would be 1, 2, 3, 4, 6, and 12. And so when we look at these numbers, right, we think, okay, there are some common factors that they both have, right? They both have 1, they both have 2, and they both have 4, right? So the highest number that they both have as a factor would be obviously 4, okay? So right now my GCF is 4, right? But it's not just 4, okay? Because we're wondering, right, out of the coefficient and the variable part of this term, what do they have in common, okay? And it can be helpful if I was to expand this, okay? Because again, an exponent is just a shorthand way of saying this thing multiplied by itself that many times, okay? So this would be saying 4 times x times x times x plus 12 times x, okay? And so looking at these, This has 3x's, right? This has 3x's along with it. And this only has 1x, okay? So what I could say here is that in common, right? Even though this one has more x's, I could say in common, they both have at least 1x, right? This has an x and this has an x, okay? I couldn't say they both have at least 2x's because this doesn't have that. I couldn't say they both have at least 3x's because this one only has 1, right? So in common, they both have at least 1, even though this has more. So in my GCF, I would just say 4x, okay? And so a shortcut for that too, when you're wondering what's the variable part of the GCF, right? You look at if they all have a variable, you look at whatever the lowest exponent is, and that's going to be included in your GCF, okay? If there was like another number in here, like let's say it said plus 16 or something, and that didn't have an x, then there wouldn't be, because they wouldn't all have then at least one x, right? We wouldn't include an x in the GCF, but that 16 is not part of it. So I hope that makes sense, that, right, because this just has 1x, yeah, we would include that 1x in the GCF, okay? Anyway, that's the big part. And there's kind of 2 steps to this. Step 1 is to find that GCF. Okay, and we found that, which is awesome. Okay, so step 2 is to do what I call reverse distribute, right? Because again, it's the reversal of this process, right? So what I found, if you kind of compare this to this, what I found, 4x, is that number that's outside, right? And that's a good thing to observe because this GCF is going to be written on the outside of my answer, right? Because I said the answer should look like the beginning of a distribution problem, okay? So what I have to determine now is just, okay, what's going to be left inside of here? And we know the answer is going to be x squared plus 3, but how would I get that, okay? And so again, it's key to remember this as reverse distribution, okay? So to reverse distribution, we think, okay, distribution normally is multiplication, right? Multiplying this 4x times both of these, okay? So reverse distribution, you might be following me here. Reverse distribution is dividing, okay? If I want to like undistribute or reverse the distribution process, I have to divide, right? Because division is the opposite of multiplication. And that's what I do. That's what I do to get these 2 inside terms, okay? So 4x cubed divided by 4x, and again, you can write the 1 exponents on there, okay? So 4 divided by 4 would be 1. X cubed divided by x to the first, okay, again, if that's tricky for you, you would subtract these exponents to get x squared, okay, so 3 minus 1 is 2. And then this one, 12 divided by 4 would be positive 3. And then x to the first, just 1x divided by 1x on bottom, those both cancel. Okay, so you're left with just 3. Okay, and that would be the answer. That would be the answer, 4x times 1x squared plus 3. The key is that GCF is the number that's written, or the term that's written on the outside. Okay, so there we go. Okay, like I said, 2 more, and then we are donezo. All right, we've got 2 and 3 up here, and we are going to factor these, or reverse distribute, okay? First step is to find the GCF, okay? So again, here, number 2, I have 3 terms in this group. Wow, 3 terms, okay? So yes, all the terms have to have it in common for it to be included within the GCF, okay? So again, I know I'm walking through this slowly, but you might be able to think, okay, 10, 15, and 20, you might be able to think, okay, this is the highest number that multiplies to get all 3. But just in case, again, it never hurts to make your list, okay? Again, you're just listing what are all the pairs of numbers that multiply to give me each of these, okay? You can always use a calculator too to check these if you're not good with your times tables, okay? So the highest number that's included in every one of these lists is, as you may have guessed, 5, okay? 5 is the highest common whole number that is multiplied, that could divide evenly out of each of these, okay? So 5 would be the coefficient, okay? But again, you look at the variable part too, okay? 10x to the 4th, or again, that would be 10x, x, x, x. 15x to the 3rd, or 15x, x, x. 20x squared, or 20x, x. Okay, so what would you say? You'd say in common, right? Some of these have a lot of x's, some of them have just a couple x's. But in common, how many could we say that in common they all have? They all have at least 2, right? They all have at least 2 x's. Even though some of them have more, we could say in common they all have at least 2. And again, your shortcut is if they all have an x, you pick your lowest exponent out of those. So 5x squared would be my GCF, my full GCF, okay? So that is step 1, is to find that GCF, okay? And then step 2, we are going to divide out that GCF from all of these terms, okay? So each of these being divided by 5x squared, 5x squared, 5x squared. And as you do this too, I would just jump right into, just so you don't forget, this is a good spot to write that GCF outside of your group. Because again, I can't tell you how many kids forget that. Okay, they forget to write their GCF outside of the group like this. Okay, so just right as you divide it, make your little template here, your GCF's on the outside, and then we just have 3 terms to get in this group. Okay, so we just go down the line. 10 divided by 5 is 2, and then I subtract my exponents. X to the 4th divided by x squared. So 4 minus 2, x squared, right? 2 exponent. 4 minus 2 is 2. Second one, 15. 15 divided by 5 is positive 3, okay? And then 3 minus 2 gives me 1. So 3x to the 1st. Lastly, 20 divided by 5 is 4. X squared divided by x squared, 2 minus 2 is 0. So you don't have to write x to the 0 because both of those x's would cancel. So this would be it right here, okay? And again, how do you check your answer? You might already know. If you want to check your answer, you can redistribute that 5x squared, right? You can kind of do 5x squared times 2x squared, 5x squared times 3x to the 1st, 5x squared times 4. And when you distribute it again, you should end up right where you started. Number 3, 18x to the 4th plus 24. Okay, so again, 2 steps. Step 1, what's the GCF? So again, we look at 18 and 24. Okay, 18 and 24. Those are all the pairs that multiply to get each one. So the highest number that is in both lists would be 6. Even though they have a lot in common, they both have 6. Okay? Now, tricky. With your variables, okay? 18x to the 4th plus 24. No variable here, right? No variable with the 24. So what does that mean? That means if this doesn't have a variable, we are not going to include a variable in the GCF. So the GCF is just 6, okay? Because again, the key here is common, greatest common factor. So we could not say that these have any variables in common because this doesn't have any, okay? Okay, which means just 6. And you can have that. Sometimes terms don't have a whole lot in common, just like people. And that's okay. But we can still factor out this 6 and still answer the question. Okay, so you divide both of these by the GCF. Okay, and again, GCF's written on the outside here. So 6 times 18 divided by 6 is 3. And then x to the 4th divided by nothing. So you guessed it. X to the 4th stays there, okay? And then the second term, 24 divided by 6 is positive 4. And again, you can check by redistributing that. Or here's another thing too, okay, to make sure you divided right. And you sometimes it's tricky too. Like if you don't make your lists, you might have said, oh, 3 is my GCF, okay? Another key is that when you divide out a GCF, there should be no other common factors in the group here. So just real quickly, if you chose 3 as your GCF, you would end up with 3 times 6x to the 4th plus 8. If you said that, you factored out a common factor, but you did not factor out the greatest common factor. Okay, so it's your job to find the greatest or the highest one. And how do I know this 3 is not the GCF? Because you see both of these numbers are still even, okay? And all even numbers have a common factor of 2. Right? All even numbers can be divided by 2. So that tells me that, okay, there was a higher number that you could have picked. Okay, so you would have to start over again and do with 6. Okay, so something to look for there. All right, I'm going to wrap up there, and I'm going to do some other GCF problems in a later video too, but that's all for now. Thanks for following. Good job.